is officially day 7 of geometry, and you guys are at the halfway point, which is crazy. We're halfway done with geometry. Let's think about. It is Thursday, June 5th, and we're going to look at this do now. So, number 1, I have a triangle here with A, B, and C labeled, and then those 3 angles are labeled with different measures. And I want to find the measure of angle A. Now, I don't know what X is, so I can't just right off the bat solve for angle A. What will I have to solve for first? Yes, Titania.
You gotta find the perimeter of the whole angle.
You got to find, say it again.
You have to find the perimeter of the whole angle.
Very, very close. I think you're thinking of like the measure of the angle. Perimeter, we're going to learn about in the next unit, actually. Perimeter would be like the length around the whole triangle. But yes, we are going to need to find the measure.
Solve for X.
Yes, we're going to solve for X. Good. So, how could I solve for X?
By adding them all together.
Add them all together? So, like, add all of these values together?
Yep, equal to 180.
Okay, and equal to 180. Every triangle adds up to 180 degrees, those angles. So let's just start with x plus 84. And then we'll add that to 54 plus x.
Plus
And
60
then, yes, plus 60
equals 180.
equals 180.
So now you add up 2 x's and you get 2x.
Perfect. Geom's here. All right, and Jean, we're working on the do now. There's copies up here at the front of the room if you want one. That way you can follow along a little better. You're welcome. Oops. Okay, so Titania, you said
You add up 2 x's and then it becomes 2x.
perfect. So I'm combining like terms here. I have x plus x, and that gives us 2x.
And then you add the rest of them and it comes to 120, 198.
Ah, okay. So you added 84, 54,
And 60.
and 60.
You get 194.
Okay.
198, I meant that. Plus
Perfect.
198
So plus 198, correct?
equals 180.
Perfect. I'm going to cross those out. Set that equal to 180.
Now you subtract 198 from 198 and 180.
Perfect. So I'm going to subtract 198 from both sides.
Now you cancel out the 198
Mm-hmm.
and then you bring down your 2x. And that's going to equal negative 18.
Good. Negative 18.
Now you divide 2 from both sides.
Perfect.
And you cross out your 2 and you bring down your x. And that's going to equal x equals negative 9.
Perfect. Okay, so we have solved for x. We just added all these 3 values together, set them equal to 180. We combined our like terms. We solved x equals negative 9. So now that we have the x value, who, by raising their hand, can tell me next, how do I solve for angle A? Erica.
84 minus 9.
84 minus 9. And how do you know, like, how do you figure out to do that?
That's the value of x.
Yes, exactly. Both of you. So our x is negative 9. It's x plus 84. So if we were to just plug it in exactly how it's written, instead of x plus 84, we're doing negative 9 plus 84. And when you add a negative, it's the same as subtracting. So just like Erica said, we could just do 84 minus 9. And that gives us what? 75. Good. So angle A is 75 degrees. Did anybody go a step further and solve for angle B? Yeah.
B is 45.
45. Very nice. Is that what you were going to say, Shayna? Perfect. How did we get 45? Yes, let's do that. So there are two different ways we could do this.
Right.
We could take our x value. Here, let me move this a little out of the way in case anyone's writing that. We could do the same thing we did to solve for angle A, where we plugged in the x value into this. So it would be 54 plus x, and x is -9. And 54 plus -9 equals 45. So that's one way we could do it. The other way we could do it is we could say, I know that this angle C is 60 degrees. I know angle A now is 75 degrees. And I know that all three of these angles together make 180 degrees. So we could set up another equation like this. I could do 75 plus 60 plus angle B equals 180. Now this way takes a little longer, but it works. So if I did this, 75 plus 60, what does that give me?
135.
130?
5.
135? Okay, yeah, 135 plus B is 180. And what would I do from there? Subtract 135 on both sides. Those would cancel, and I would get B equals the same thing, 45. Perfect. So you can do it in a few different ways. Whichever one makes more sense to you, that is fine with me. Okay, so there we go. We've got all three measures. Anybody have questions about number 1 before we do number 2? Okay, I'm gonna wait just a minute before we do number 2, just because I see a few of us still writing, and I want to make sure that we are all ready to move on. Go ahead and move to number 2. I'll keep it to where you can still kind of see number 1. For number 2, you have a slightly less complex question. You're just finding the measure of angle B. And we know the measure of A and C already. So, who would like to tell me how they did this? Barbara, can you tell me?
3 plus 70.
B plus 70 plus 60, good, equals 180. We're doing the same thing, adding all three angles equal 180. So what'd you do next, Barbara?
70 plus 60.
70.
130.
Perfect. 70 plus 60 equals 130.
3 plus 180.
B plus 130 equals 180.
Subtract 100 from the side.
Yes. And we subtract
3 equals
30 from both sides. 130s cancel. So we get B equals 50. Very nice. Okay.
You always want us to put the degree sign when it comes to like that.
Technically, if we're finding an angle measure, it's good to write the degree sign, because that's what we're finding is degrees. But, I mean, I'm not gonna count you wrong if you don't, but it is a good habit to be in. So, yes, you should. Okay, any questions about either of these problems? I'm gonna leave this up here for just a second, and let me grab some stuff that I'm gonna use to teach you the next topic. So I'm gonna pause this for a moment. All right, so like it says here on the bottom of our do now, today's topics. I'm going to read the first one to you, and then we'll get into it. So we are going to talk about triangle side length. We've been talking about angles, but now we're going to move on to the sides of the triangle. So what we will learn about today is that the sum, or when you add together the length of any two sides of a triangle, that answer it must be greater than the length of the remaining side. And we're going to make sense of that on the next page here. I'm going to put this to the side and show you another little demonstration. So I have a bunch of popsicle sticks, and we are going to think of these as the sides of a triangle, like this. Okay. So if I have a triangle like this, what we're saying is that if I add the length of two sides of my triangle, they have to be a longer length than the third side. So we could see here, if I were to pull these sides out and make a straight line with them, those two sides added up are much bigger than the other side. Now, there's a reason that they have to be bigger than the other side, and I'll show you an example of that. What if I used a popsicle stick, or sorry, a triangle side that is got two sides that add up to the exact same length of the third side? If I tried to make a triangle out of this, here's where they connect. No matter how tiny of an angle I make this, that third side will never fully connect. I can't make a triangle with it. Now, this is kind of a cheat because, well, my popsicle sticks aren't exact. But if this is the exact same length here, as soon as I open it up to try to make a triangle, no longer will these touch each other, okay? It won't mathematically work. We could also look at it like this. If my two sides add up to smaller than my third side, you can see that if I try to make a triangle out of these three shapes, you just can't. The only way to do it is by shortening that third side. Okay, so let me show you how this works with numbers to make it make a little more sense. Let me grab my notebook. So, let me pause this, and I'm going to grab my copy of my notes real quick. So, I'm going to have you guys take a few little notes, and I'm going to ask you a few questions about this. So, I'm just going to start by titling my page, Geometry, Unit 2. And this is our day 7 notes. The title of what we're talking about today is the triangle inequality theorem. Triangle inequality theorem. And we use this to decide if I give you three different lengths we should be able to look at those links without trying to draw a picture or anything and say, can these three links make a triangle? Yes or no? And here is kind of the formula for that theorem. The sum of the two shorter sides must be greater than the length of the longest side.
Good.
We can put this in simple terms by saying A plus B, because remember A and B are my shorter sides, greater than C. C is always the longest side. And sometimes it helps to see a picture of that, so I'll just draw a little triangle over here, and I'll call it A, B, C. And we'll get some examples to show how we use this. So, for example,
Let's see.
if I have a triangle with these three side lengths, let's say I have 3 inches is one side, 5 inches is the other side, and 10 inches is my third side. The question we would ask is, can these three sides make a triangle? So here's how we would test it. First, I'll make a little step list. So step 1, circle the longest side. So for this first problem, out of 3 inches, 5 inches, and 10 inches, which one is the longest? 10. So I'm going to circle that. Now, step 2, use a different color here. Step 2, we are going to add the remaining sides. So I'm adding 3 plus 5. And so now I ask myself, first of all, what is 3 plus 5? 8. 3 plus 5 is 8. Okay, so now for the third step and the final step, we're going to compare that sum to the biggest side. If the sum is greater so if it's bigger than the number we circled, then it is a triangle. So let's ask ourselves, 8 greater than 10. 8 is greater than 10. Is that true? No, this is not true. So if you end up with an answer like this, we say it is not a triangle. This triangle cannot exist. And that's all you did. We could look at it visually if you want. I'll draw this kind of on a little sticky note just to show it for fun while y'all are copying that down. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is a 10-inch segment. And then, well, let me get ruler. See if that lines up with anything. One, 2, 3, 4, 5. And then 1, 2, 3. So if I had these 3 side lengths and I tried to form a triangle out of these 3 sides, it's just not going to work. I could try taking this 5-inch, which I'm going to say is about 1 1/16 of an inch right here on my ruler. So I could try to like draw that on here with a really small angle to make it fit. Let's see. Okay, so there's that side. There's my 5-inch side. If I try to add that 3-inch side on, which comes up to be 1/2 inch-ish, I mean, no matter how I put these together, it's never gonna make a triangle. Those sides are just not gonna meet each other. They're gonna pass each other up. Okay, we can't make a triangle with that. We just can't. So let's look at another example. What about, let's see, how about 152 inches, 180 inches, and 31 inches. Why is that a triangle?
Let me make sure I got this right.
So let's go step by step. First, what would be my longest side? 180. So I'm going to circle 180. And what will I do with the remaining 2 sides? We're going to add them together. So over to the side here, I'm going to write 152 plus 31. I'm going to stack them up. 2 plus 1 is 3. 5 plus 3 is 8. 1 is 1. So now I've done that. And I can ask myself, is 183 greater than 180?
Yeah.
Yes. So because it is greater, this is a triangle. We would say yes. This is a triangle. Perfect. Give you another one. How about here's a tricky one. 3 inches, 15 inches, 12 inches. 3 inches, 15 inches, 12 inches. Yes.
It would just make a line.
It would just make a line. You're correct. How do you know that? What happens?
12 plus 3 is 15.
Yes. So let me work this out. We're gonna come to the same conclusion. What's my longest side?
15.
15. So what will I do with my remaining sides? Add them together. So 3 plus 12 is what? 15. So I'll write that side 3 plus 12. So now we move to that step 3. We need to ask ourselves, is 15 greater than what I circled? 15?
No, it's equal.
No, it's equal to 15. So if you end up getting the same number as that longest side, that's not a triangle. It's not greater, it's equal to. So no, not a triangle. Because that is not true. 15 is not greater than 15. So I'm going to give you guys a few of these to try on your own. See if we got this. Before I write down some problems, does anybody still need to see this or can I do this?
A little bit.
Okay, so let me see. Um, Question that you'll see whenever we have problems like this. Say, do the 3 given side lengths form a triangle? problems here. You're gonna try to do all 5. Feel free to help each other out. Help each other out, talk about it, compare your answers, see if you guys are getting the same things. I'll set a little timer for us.
You just want to write yes or no?
You can just write yes or no. You can say yes, they make a triangle, or no, they don't make a triangle. Just make sure that you're showing your work. So I know you're not making a guess, not that I think you do that. But just a note for everyone, show your work. I do want to see that biggest side circled, and I want to see the addition problem where you're adding the smaller sides together. So I'll pause this and give you guys some time to try that. Go down the line. Number 1, is it a triangle, yes or no?
No.
Uh-oh, I hear yes and no. Let's see. Somebody want to raise a hand, tell me how to do it? Lisa.
You're going to add, or you're gonna circle 50,
Yes.
and then you're gonna add, no one can see anything.
Ah,
No one can see anything. No one can see anything.
Corey. My bad. Forgot it was still frozen. There we go. All right. So circle 50. Then what?
Then you're going to add 12 and 28. and
Okay.
make it
12 plus 28 is 40. And is 40 greater than 50?
No.
No. So this is not a triangle. Number 1 is no. Number 2, yes or no?
Yes.
Yes. Everybody agree?
Yes.
All right. Yes. 243 is our biggest side. 8 plus 237. What is that? 245?
Yeah.
Okay, and 245 is greater than 243. I wrote that wrong. Yes.
That'd be a very obtuse angle.
Yes, it would. Super long sides. Oh, wait, actually, it would be. I thought the same thing. The super long sides, I thought, oh, it must be a super obtuse, but actually, it would make it super acute. Because if I have one tiny side
Yeah.
and 2 really long sides, see how little that makes the angle?
Mm-hmm.
Those visuals kind of help sometimes. Because I was thinking the same thing. Number 3, yes or no?
No.
Oh, no. 18 is our biggest side. 3 plus 12 is 15. Is 15 greater than 18?
Nope.
Nope. That's why it is not a triangle. Number 4, yes or no?
Yes.
Yes?
Yes.
Okay, yes, let's see. 45 is our biggest side. 28 plus 30 is 58. And 58 certainly is greater than 45. So that is true. Number 5.
Yes.
Yes? We all agree?
Yes.
Okay, my biggest side is 437. 350 plus 103.
453.
453. And 453 is greater than 437. Perfect. Everybody got that? Wonderful. Okay, the last thing that we were going to talk about today is the Pythagorean theorem. So we'll just take a very short little review of that since we have learned it before, but just in case. Under here, I'm just going to rewrite it. Pythagorean theorem. Now, this is something important to note about the Pythagorean theorem. It only works for right triangles. Only right triangles. And what is a right triangle? What does that mean? It means the triangle has a 90-degree angle in it. So, draw a quick picture. I'm going to draw somewhat of a right angle. I'm going to put a box there to show that it is right. It's 90 degrees. And I'll draw this line connecting here. And on a right triangle, the longest side is always across from the 90-degree angle. The longest side is always C. The other two sides could be A and B or B and A. It doesn't matter what order those are in. I'm just going to go ahead and write A, B here. And who remembers what the Pythagorean theorem is? Titania.
A squared
Mm-hmm.
B squared plus C squared.
Equals,
C squared.
yes, perfect. A squared plus B squared equals C squared. We use this to solve for missing side lengths of a right triangle. So, if I have a right triangle where, let's say, A is 12, and let's say B is 10, how would I solve for my missing side C? Go ahead, Kiana.
12 squared
Yes, 12 squared
plus 10 squared
plus 10 squared
equals C squared.
equals C squared. So we're just plugging in our A and our B to that formula. So I've got my equation set up, and just to review it once, what would I do from here?
Times 12 by 12.
Yeah, 12 times 12 is 144 plus 100. 10 times 10 is 100 equals C squared.
You add the 144 and the 100 together.
Perfect. And that'll give us 244. When we add those together,
C squared.
equals C squared. Now here's the special part. What do we do for our last step? Yes, Shayna.
The square root of 244 is 6 squared.
Yes, square root. So remember on your calculator, square root, we use the second button, that blue button, and then we hit the x squared, which is right next to 7. And now you have a square root. So I will type 244, enter. And let's go with 15.62. That's C. So we're doing the square root both sides. And we got 15.62 equals C. So that's our missing side length. And you can kind of relate this back to what we just learned about the side, when you add them, the sides. When you add those three sides together, or the two smaller sides, they have to be bigger than that longest side. So we can tell if we get an incorrect answer, if for some reason that does not work. Because 15.62 is now our longest side. 12 plus 10 is bigger than 15.62. That's going to be 22. So there's our review on the Pythagorean theorem. I know we have a little experience with this from last unit, so I'm just going to show this. I'm going to give you your exit ticket. If you feel great about this and you finish your exit ticket, you're free to go today, okay? If anybody wants a little more review on this, you're welcome to stay. And I know there's a few people, specifically Barbara and Titania, I still need to grade your corrections. So if you want to wait for that, you're more than welcome, but I can also email it to you if you got lazy to be. But that's going to be our instruction for today. And I'm going to pass out your exit ticket. That's it. Short lesson.